Thank you. This is a great start. We have applause already, and I haven't even said anything, which is great. I am incredibly happy to be here because yesterday night we finished printing. Well, I say we, but the CEAD team, Andrew and Ray, finished printing these incredible parts that we have just in front of us. And it is what I'm going to talk about today. How can we do tool pathing for 3D printing in large scale to achieve these really beautiful parts, in this case tooling for composites. First I will just say something about who I am. So I'm Emil Johansson. I'm the Chief Product Officer of a software company called Adaxis, and we make software that turn robotic arms into 3D printers, like the one just behind you. And we work with a lot of different processes. So these are just some. We have, of course, a lot of customers in pellet extrusion, printing of plastics, but also metal, various kinds of welding-based and wire laser-based systems. This is our software, so it's meant to be as easy and intuitive as possible, making it, well, removing as much as possible of the complexity that is inherent by a robot, and also 3D printing itself, so that you could use these massive printers just as if they were a desktop printer in your office. That is our goal. This presentation will focus on tooling, which is one of the verticals where we have a lot of customers right now. And why would you want to print a tool or a mold for composites? Well, there are two main reasons when we ask these questions in additive manufacturing, and it's reduced lead time and reduced cost. And basically all other advantages are based on those two. But there is a third one that we can highlight, which is recycling of materials. So if you print a tool in thermoplastic, you will do it faster, cheaper, but also you can ground it up when you're finished with the tool, print another one, which is really great. I said that we want to be able to use these robotic arms as if they were a desktop printer, but it's very difficult to get away from the fact that we are printing something that is orders of magnitude bigger than what you do on a desktop printer. And there you have a bunch of issues that appear right away, which is warping, distortion of the part, we have anisotropic properties, we have, of course, a much longer print time, potentially, and much more material usage. So a lot of what we do when we design tool paths is to avoid a bunch of these issues, and doing that as automatic as possible. The part that you see printed here is printed also right now live in the robotic cell, and it is interesting from many different perspectives. So because it's a tool and has to be machined, we need to have some rigidity to this part. We have to also have some cutouts so we can move it with a forklift. We have to have reinforcement of some parts of this component. So there are a bunch of different properties and things that we need to consider when we are 3D printing that. And of course, this is where I get really excited, because I get to do a lot of these really cool, super detailed stuff, like adding double beads and optimizing start and stops, making sure we have internal stiffeners and so on. The good thing about what we do is that we are not alone at 3D printing, in the 3D printing market. We work with great companies like AirTech and CEAD, who help us do this really effectively. So that's why we are now very happy to launch a much simpler way of producing the toolpaths for these parts, so that you can print them, you can program them much faster, and you can ensure that you get the final part out the first time. This video then shows that you select the material, you select the tooling surface, you select the back of your tool, And then to guide the stiffener generation, you select a guiding edge. And then you can play around with some sliders to make sure that you get exactly the kind of stiffeners you want. You add forklift cutouts in, which I find incredible, is the forklift cutout generator. It's a great feature. And then you get these toolpaths optimized, and with the help of AirTech, optimized in a way that makes perfect sense for tooling generation. When we have done that, of course, there are always like these small details that we want to change. So in this case, we have a couple of different interesting areas on this part, which is the wiping. So generally, when you print in large scale, you never want to do start and stop. It's like the most annoying thing ever. But with proper process control and a good toolpath, you too can do start and stop. And the key to do that is, of course, the wipe movement. So in this part, we have at least two different kinds of wipe movement, where we wipe against the outer bead, and then we do a backwards wipe. And that really seems like a ridiculously small detail, but that's the key between like this amazing successful part and one that looks like shit. And to really solidify that point, I have these two videos that I will attempt to play. The first one, showing the backwards wipe. So here it's really key to get all of the overlaps right, all of the movements right, everything has to be super smooth. And then you get this really clean cutoff, and you can see it on the part right here. The second is of course wiping against the outer bead, which we will see here, and that allows us to get a really nice closure on this side of the part as well. So what we have is a workflow that will remove most of the manual work that is typically involved in creating a toolpath for a mold. Typically, you do all of this work in CAD. You model all of these surfaces in a very laborious process. All of the offsets have to be perfect. You enter it into the slicer, and you find out that one offset was not perfect. You have to go back into CAD, or you want to modify the angle of something, you have to go back into CAD. All of that now happens automatically. And then we have a toolpath editor, which allows it to go in and add these extra small little details like the wipes. As I mentioned, we are very fortunate to work with great companies, and some of them are here right now in this exhibition. Of course, CEAD, who is here, and AirTech, very close by. Velotti in Hall 6, and CNC Robotics as well. And we work with a lot of companies, and we're so grateful to be part of this great ecosystem. We are just over there doing software demos live, and we're happy to talk about how to generate the best possible toolpath for a mold or any other part that you would like to print. Especially boats gets me really excited, so if you have that would be great. And I'm very happy that you stayed to listen. Thank you very much.